Limit of the rational function. Again, we're supposed to look at the denominator. We have to make sure that if we are going to replace this x by whatever x is approaching to, we are not going to have 0. But in this case, we have 7 minus 7. This is going to give me 0. So what we're supposed to do next, we're supposed to look at the numerator and check, maybe we can factorize the numerator and do cancellation of the denominator, if this is going to be possible. Now, anytime I approach that kind of problems, I always look at the position of x. I prefer to have x first. I have numerator, my x is always at the first position, and in my denominator, x is on the second position. So what I used to do, I simply rewrite this problem as limit x approaches 7, copy numerator, have x squared minus 12x plus 35, and rewrite denominator as, I'm going to factorize negative sign, x minus 7. Because I have x first in my numerator, I'm going to keep x first in the denominator too. So, we're supposed to factorize the numerator. This is going to be equal limit x approaches 7, and in the numerator I'm going to have x minus 7, x minus 5. And in the denominator I have negative x minus 7. Please notice that we have multiplication. Anytime we have multiplication, we can simply simplify. We can reduce x minus 7 with x minus 7. And what are we going to have over here? Negative 1. So my expression is going to look like this right now. I have limit x approaches 7, and I have invisible positive divided by negative. I'm going to have negative x minus 5. I have the limit of the polynomial, and I simply replace x by 7. I'm going to have negative 7 minus 5. 7 minus 5 is equal 2. I'm going to have negative 2. This is the solution to my problem. Let's take a look at this example. Again, we have the limit of the rational function. We're supposed to look at the denominator, like always. And what we have? X minus 3, with x approaching to 3. 3 minus 3 gives me 0. We said we do not want to have zeros at the denominator. So what we're supposed to do next? We're supposed to look at the numerator. Remember I said I don't like having x's somewhere in the back. I prefer to have them at the front. So what I'm going to do, I'm going to rewrite this function and simply write limit x approaches to 3, and I'm going to factorize negative sign, and I'm going to have negative x cubed minus 27. When I have x at the front, I feel more comfortable. But if it's okay for you, you can keep x at any position. If you can see the problem looking very simple, with x at any position, it's okay. But let's say I want to make this very clear for students. That's why I try to keep the x at the first position and all other numbers next to it. So I'm going to have x minus 3. I have difference of cubes. Are you seeing that? You can rewrite this as limit x approaches to 3, and I'm going to rewrite this as x to the third minus 3 to the third over x minus 3. I'm supposed to use the formula for the difference of cubes in the numerator. So I'm going to rewrite this as limit x approaches to 3 negative, and I'm going to have x minus 3, and I'm going to have x squared plus 3x plus 9. In the denominator, I have x minus 3. We have multiplication, that's why we can reduce x minus 3 and x minus 3. At this moment, we eliminated uncomfortable denominator. And my expression right now is going to look like this. I have limit with x approaching to 3, x squared plus 3x plus 9, of course, negative. I have limit of the polynomial. Anytime I have limit of the polynomial, I simply replace every single x by the value which x is approaching to. In this case, I have 3. I have negative 3 to the second power plus 3 times 3 plus 9. I have negative 9 plus 9 plus 9. 9 plus 9 plus 9 is 27. Negative answer is negative 27. This is the solution to my problem.